Good evening, students. Today we are going to discuss the mole concept exercise 5B numericals. Previously we have completed 5A numericals. Now in this 5B, the first one is question number 4. They have asked you to calculate the relative molecular mass of these compounds and some elements are given here. So atomic mass of few metals they have mentioned here. So how to calculate this? You already are familiar with this. The individual atomic mass of all elements you have to add here to get the molecular mass of the whole compound. Now example, if you calculate the first one, ammonium chloroplatinate. In this, let me write nitrogen, atomic mass is 14 AMU, hydrogen is 1, platinum is 195.1, chlorine is 35.5. So these are the individual atomic mass. Now if you add this, we'll get the molecular mass. So PtCl6, ammonium chloroplatinate. Now first and foremost thing, for nitrogen and hydrogen, let us combine. For ammonium, how can we write 14 plus, this is 4 square, into platinum 195.1, we need to add this. Next, for chlorine 35.5, number of atoms are 6, so multiply with the 6 here. Now take it as separately, 18 into 2, 36, 195.1 and 35.5 into 6 will calculate here, 6 5 is 30, so here 30 plus 3, 33, 6 3 is 18, 21. So we get 213. For Cl6 we get 213, add this. So 444 atomic mass unit or unified mass, anyone can be written. So for first one, ammonium chloroplatinate, the relative molecular mass, here we got 444.1 atomic mass unit. Hope you have understood this. Similarly, following the same method, calculate the molecular mass of potassium chlorate. First and foremost thing, write the atomic mass here. Potassium 39, chlorine 35.5 and oxygen is 16. Next, what is the molecule here? KClO3. So potassium 39 plus chlorine 35.5 plus oxygen 16 into 3. So individually if you add this, what you get? 39, 35.5, 16 into 3 we get 48. So 9, 17, 22. So we got 122.5 atomic mass unit. Second one, for potassium chlorate we have calculated the molecular mass and we'll write the answer here. Nothing but 122.5 atomic mass unit. So first two completed. Next, blue vitriol, formula CuSO4.5H2O. We call it as copper sulfate pentahydrate. How do you calculate the molecular mass? Before you start, write down atomic mass. Copper 63.5, sulfur is 32, oxygen 16, and water directly will write the molecular mass of water, 18. So we can write it. Next, CuSO4.5H2O, we have written the formula. Individually copper 63.5, sulfur 32, and oxygen 16 into 4 plus 5 into 18. So 18 is the molecular mass of water. We have 5 water molecules. Now write one below the other so that you don't commit any error here. 16 into 4, 64, and 18 into 5. So 8 5 is 40, 90 we get. 4 5 6 9, then 15. So we got 249.5 atomic mass unit. So for blue vitriol, 249.5 atomic mass unit. This is the molecular mass. Next one is ammonium sulfate. Calculate the molecular mass of ammonium sulfate. You can try to solve this and later you verify the answer. So for writing ammonium sulfate, here we know that NaH4 directly we calculated it as 18, sulfur is 32 and oxygen is 16. Now to get the molecular mass, add the individual atomic masses. So 18 into 2 plus sulfur 32 and oxygen is 16 into 4. One below the other you take to avoid errors. 18 2 is 36, then 32 and 16 into 4 64. We get 1232 atomic mass unit. Hope you have understood this. Ammonium sulfate, the molecular mass is 132 atomic mass unit. Next one is sodium acetate. How do you calculate sodium acetate? The formula is CH3COONA. So CH3COONA. We can do one thing, add all the atoms which are similar here. Carbon we have 2 atoms, H3 and O2Na. So you can write the molecular mass in this manner, which is easy to calculate. Atomic mass of carbon 12, H is 1, O 16 and sodium is 23. So by adding this we get the molecular mass. So first one is 12 into 2 plus second one 3 plus 16 into 2 plus 23. So writing this one below the other, 24, 3, 32 and 23, we get 1282. So the molecular mass of sodium acetate is 82. So we get 82 atomic mass unit. Next, solve the molecular mass of chloroform, CHCl3. CHCl3, atomic mass of carbon 12, H is 1, chlorine is 35.5. So now add this 12 plus 1 plus, so nothing but 35.5 into 3. So 15 plus 1, 16. We get 106.5. 106.5. Taking it one below the other, we get 0.5679. So 119.5 atomic mass unit. So for chloroform, the molecular mass is 119.5 atomic mass unit. Now the last one is ammonium dichromate. Let us write ammonium dichromate. Hope you are following this very easy method. So ammonium NH4 taken twice here, ammonium dichromate. First and foremost thing, ammonium 14 plus 4 we have 18, the molecular mass. Next for chromium 52, oxygen is 16. So on taking this we get 18 into 2 plus, so chromium is 52 and number of atoms 2, 52 into 2 plus oxygen 16, 7 atoms. So add all this, 18 into 2, 36, this is 104 and 16 into 7, 7 6 42, 112. So we get the answer, 252 atomic mass unit. Now the molecular mass of ammonium dichromate is 252 atomic mass unit. Hope you have understood this. We have completed question number 4, that is finding out the relative molecular mass of the given compounds. Let us move to question number 5. Now question number 5, we need to find out number of molecules in 73 grams of HCl, weight of 0.5 mole O2, number of molecules in 1.8 gram water, and number of moles in 10 gram calcium carbonate, and mass of 0.2 mole of H2, and number of molecules in 3.2 gram of SO2. For all this, you know that 1 mole of any molecule of or gas or elements contain Avogadro number, that is 6.023 into 10 to the power of 23 molecules or atoms or ions. So we need to remember this first one, that is 1 mole has 6.023 into 10 to the power of 23, that is Avogadro number. Based on that you can calculate all these sums. Now number of molecules in 73 grams of HCl. First and foremost thing, they have mentioned 73 grams of HCl. So if you consider one HCl molecule, it has 35.5 is chlorine, so we can take it as 36.5 grams for HCl. So the molecular mass of HCl, that is for 1 mole, it is 36.5 grams. So let us write like this. So 73 grams of HCl we need to calculate, therefore take it as X. And we know that 36.5 grams of HCl has Avogadro number 6.023 into 10 to the power of 23 molecules. Using this, now we can solve, cross multiply, what we get, 36.5 X is equal to 6.023 into 10 to the power of 23 into 73. Therefore X is equal to, we need to calculate number of molecules in 73 grams, that is X is equal to 6.023 into 10 to the power of 23 into 73 by 36.5. So 1 and 2, so into 2, therefore roughly you can take it as 12 into 10 to the power of 23 molecules, and we need to satisfy according to the scientific notation, therefore we can write it as, so 1.2. So 1.2 into 10 to the power of 24 molecules. So nothing but number of molecules in 73 grams of HCl is 1.2 into 10 to the power of 24 molecules. Hope you have understood this. We have written the answer here. Coming to the second one, what is the weight of 0.5 mole of oxygen? For this, let us write, if you are taking 1 mole of oxygen, what will be the mass? First let us calculate that. So 1 mole oxygen, nothing but 16 is the atomic mass of oxygen into 2, we get 32 grams. So first and foremost thing, 1 mole has a mass of 32 grams. So what is 0.5? Let us write like this. So 0.5 mole of oxygen, take it as X, cross multiply. What you get? X is equal to 32 into 0.5, nothing but 16 grams. Hope you have understood this. So 1 mole has 36 and half mole, nothing but 0.5 will have 16 grams. So here we can write the answer 16 grams. Hope you have understood the second one. Now coming to the third, number of molecules in 1.8 grams of water. So if you write here, you know, for water molecular mass is 18 grams. So 18 grams of water contains Avogadro number 6.023 into 10 to the power of 23 molecules. First one is already known to us. Now the question is, what is the number of molecule in 1.8 grams? Therefore 1.8 grams is equal to X. Cross multiply, you get 18X is equal to 6.023 into 10 to the power of 23 into 1.8. Now what is X? X is 6.023 into 10 to the power of 23 into 1.8 divided by 18. So we can take like this, 1.8 and 10 times. So 10 here, 23. So what you get finally, 6.023 into 10 to the power of 22 molecules. Hope you have understood this. 18 grams is Avogadro number, 1.8 is nothing but 22 molecules. Hope you have understood this, very simple. Similarly, how to calculate number of moles in 10 grams. For that you should know, for 1 mole what will be the calculations. So calcium carbonate, calcium atomic mass 40, carbon 12, O3 is 48. So we get the molecular mass for calcium carbonate is 100. So we can also convert into, if you take gram gram atomic mass or gram molecular mass will be 100 grams. So we can write like this. 1 mole of calcium carbonate, the weight is 100 grams. Now they are asking for 10 grams, how many moles you get? Take it as x, cross multiply. 100x is equal to 10, x is equal to 10 by 100. So we can take 0.1 mole. Hope you have understood this. 100 grams is 1 mole, 10 grams will be 0.1 mole. So 0.1 mole. Next one, what is the weight of 0.2 mole of H2 gas? Fine, let us write. See, hydrogen, if you write 1 mole of H2, the weight is 2 grams. You know that H is 1, so 1 into 2, 2 gram. Now they are asking what is the weight of 0.2 moles of H2. Take it as x, cross multiply. So x is equal to 0.2 into 2, nothing but 0.4 grams. Hope you have understood this. 1 mole is 2 gram, 0.2 mole is 0.4. So here we will write it as 0.4 grams of H2 gas. Hope you have understood this. Next, number of molecules in 3.2 grams of SO2. For that, let us calculate SO2, sulfur 32, oxygen 16 into 2, 32. You have 64 grams. We can write it as 1 mole of SO2 has a weight of 64 grams. Now they are asking number of molecules in 3.2 grams of SO2. See, you know that 64 gram Avogadro number 6.023 into 10 to the power of 23 molecules. From this statement, we know that 1 mole has a weight of 64 grams. It contains Avogadro number of molecules. For 3.2, let us take number of molecules as x. Follow the same method, cross multiply. 64x is equal to 3.2 into Avogadro number. Therefore, x is equal to 3.2 into 6.023 into 10 power 23 by 64. So we can cancel this. So this is 1 time 20 we can take. Next this you can cancel. So 2 with the 10. So we can take it as approximately 3. Now 10 and 10, 22. Therefore, we get 3 into 10 to the power of 22 molecules. Hope you have understood this. On calculating, you get for 64 gram, it is Avogadro number. For 3.2, it is nothing but 3 into 10 to the power of 22 molecules. Hope you have understood this. Now let us move to question number 6. Next, question number 6, they have mentioned which would weigh the most. So we need to calculate which has maximum weight here. First one 1 mole water, second 1 mole carbon dioxide, third 1 mole ammonia, and fourth one is 1 mole of carbon monoxide. So if you calculate this, you know that for H2O it is 18 grams. 1 mole is 18 grams. We already know how to calculate 2 and this is 16. So we get 18 grams. 1 mole has 18 grams weight. Second one, carbon dioxide, nothing but 12 and 16 into 2. So we have 44 grams in 1 mole of CO2 molecules. Now for ammonia, you have N is 14 and 3. So we have 17 grams in 1 mole of NH3. First one 18, second 44, third 17, and the last one carbon monoxide 12 and 16, nothing but 28 grams. So looking at this, you can easily identify that the weight of 1 mole CO2 is maximum here and the least is NH3. Now let us move to question number 7. Question number 7, which contains maximum number of molecules among 4 gram oxygen, 4 gram ammonia, 4 gram carbon dioxide and 4 gram SO2. Because they have given same mass, we can apply this formula, nothing but number of moles is equal to given mass by molecular mass. Given mass by molecular mass. Another method is also there, but it is lengthy, so we can follow the simple method. If you calculate number of moles, you can easily identify the number of molecules. First one, mass by molecular mass for A. What is the mass here? 4 grams. Molecular mass of O2, nothing but 1 is 16 into 2, so we can directly write it as 4 by 32. So number of moles in the case of 4 gram oxygen is 4 by 32. Second one, again the same mass, 4 gram by NH3 is 17 for C, 4 by, so carbon 12, this is 32, 4 by 44, and the last one D, 4 by, this is 32 plus 32, therefore you get 64. So very simple. Because the mass is same, we have taken this formula. Otherwise, you have to write like this: 1 mole is equal to Avogadro number. Therefore, what will be the mass here? You can calculate. So 4 by 32. Where you have least denominator, you have, in the case of ammonia, it is least. Therefore, the value will be maximum. Therefore, maximum number of molecules here is, in the case of 4 grams of NH3. To calculate how much, let us take like this: 17 grams for 1 mole. You can take 17 grams has 1 mole, nothing but 6.023 into 10 to the power of 23 molecules. Now what is 4 gram? You can take it as x, cross multiply, and you can get the value of number of molecules also, but the value is maximum for 4 grams of ammonia. Hope you have understood this. Today we have solved question number 4 to 7 from 8th question. We will see in the next lecture. Thank you so much.